December 14th, 1942. Detroit, Michigan, 11:47 p.m. The welding torch hisses in the darkness of a cramped garage, throwing shadows that dance across oil-stained concrete. Fisher's handskelest. Steady, belonging to a man who has spent 20 years bending metal to his will guide the flame along a seam that should exist. Outside, snow falls on a city that has transformed itself into the arsenal of democracy. Inside, a civilian pipefitter named J.D. Fisher is about to change the war. He doesn't know it yet. The Sherman tank rolling off assembly lines across America in the winter of 1942 is both miracle and nightmare. A 30-ton promise wrapped in riveted armor. But there's a problem eating at the heart of production. A technical flaw so fundamental that it threatens to choke the entire war effort before it can truly begin. The hull. 5 massive pieces of armor plate. Each one thick enough to stop a rifle round. Heavy enough to require cranes and prayers in equal measure. They must become one, and the only approved method riveting is killing men before they ever see combat. You can almost hear the pneumatic hammers echoing through the Chrysler tank arsenal, the thunderous percussion of American industry. Thousands of rivets driven home by teams of workers. Each rivet a potential weakness. Each seem a place where German shells might find purchase. But it's not the structural integrity that's strangling production. It's time. Riveting a single hull takes days. Days of deafening noise, of workers stationed inside the tank breathing metal dust, of inspectors checking each of the thousands of connection points. The mathematics are brutal at current production rates. America might build enough Shermans to match German panzer output by 1945. The war won't wait that long. Fisher knows this, though not from classified briefings or military consultations. He knows it the way any working man in Detroit knows it in December 1942. From the absence of sons and brothers, from the production quotas posted on factory walls, from the quiet desperation in the voice of every foreman who walks past the tank assembly lines. So, welds. Not with permission. Not with authorization. Certainly not with the blessing of the Army Ordnance Department, which has approved riveting and riveting alone for hull assembly. Fisher works in the margins of official doctrine, in the gaps between what is allowed and what is possible. The technique he's developing isn't new. Welding has existed for decades, fusing metal with heat and pressure, creating bonds stronger than the materials themselves. But applying it to tank armor? That's heresy. The Army has reasons, good ones, they believe. Welded seams might crack under shell impact, might fail in ways that rivets, with their mechanical simplicity, never would. Might introduce weaknesses that turn protective steel into coffins. Fisher's torch says otherwise. He's been experimenting for weeks now, testing different angles, different temperatures, different techniques for joining armor plate. Each test leaves him with scraps of fused metal that he subjects to every abuse he can imagine. Hammering. Stress testing, exposing them to temperature extremes that would make a metallurgist weep. The welds hold, more than hold, they excel. Stronger than rivets, faster than rivets, cleaner than rivets. Each weld creates a continuous bond, armor plate becoming singular, unified, without the thousands of potential failure points that rivets introduce. But strength isn't the revolution. Speed is. Where riveting demands days, welding promises. Where riveting requires teams of specialized workers, Welding needs skilled craftsmen. Detroit has those in abundance. Men who've spent their lives joining metal, building cars and bridges and pipelines, now staring at want ads, seeking tank builders. Fisher can see it. Can see the production line accelerated beyond anything the planners have imagined. Can see Shermans rolling off factory floors, not in dozens but in hundreds. Can see the mathematics of war tilting in directions that might actually save the sons and brothers who woe and come home for Christmas. But vision isn't validation. He needs proof. Rariburu alano la romosha. Not the kind that satisfies a pipefitter's curiosity. but the kind that convinces generals and bureaucrats and engineers who've built their careers on established doctrine. The kind that overcomes institutional inertia in an organization that moves with all the agility of a tank itself. The torch goes dark. Fisher lifts his welding helmet, studies the seam glowing orange in the darkness. Somewhere across the Atlantic, assembly lines in German factories are producing panzers with welded holes. They've already solved this problem, already moved beyond the limitations that shackle American production. Fisher doesn't know that yet. But he's about to force everyone else to find out. January 8th, 1943. Chrysler Tank Arsenal, Warren, Michigan, 7:15 a.m. The cold bites through concrete and steel, through the massive doors of the assembly building where men gather in clusters, breathing fog into the industrial dawn. They've been summoned engineers, supervisors, army inspectors, though no one has explained why. Only that J.D. Fisher has something to show them. Something impossible. He stands beside two hull sections, each one 1,000 pounds of hardened steel, waiting with the quiet confidence of a man who has already won an argument no one else knows they're rehaving. His welding rig sits nearby, tanks of acetylene, and oxygen connected by rubber hoses that snake across the factory floor like industrial umbilical cords. The head engineer arrives last. His name is Morrison, a man whose entire career has been built on incremental improvements, on following specifications, on the sacred doctrine of approved methods. He looks at Fisher the way you might look at a street preacher claiming the end times. "You're wasting production time," Morrison sighs. Fisher doesn't answer, just strikes his torch to life. The flame blooms blue-white, hot enough to make the air shimmer, hot enough to make the gathered men step back instinctively. Fisher moves with practiced precision, torch angled just so, feeding welding rod into the joint where two armor plates meet at 90 degrees. The metal liquefies, flows, fuses. You can see it in real time separate, pieces becoming singular, the seam disappearing into unified steel. 12 minutes. That's how long it takes Fisher to weld what would require 4 hours of riveting. 12 minutes of continuous work, of flame and focus, of a technique so far into approved tank production that watching it feels like witnessing alchemy. When he kills the torch, the silence in that factory is absolute. Morrison approaches, skepticism carved into every line of his face. He examines the weld, running gloved fingers along the seam, looking for the flaw that must exist, that his training and experience demand must exist. He finds nothing. "Structural testing," Morrison says, finally. "We'll need already done." Fisher produces a welded sample from his workbench, thick armor plate, joined at the same angle as tank hull sections. He spent weeks testing it, abusing it, subjecting it to stresses that would never occur in actual combat. The weld shows no cracks, no separation, no weakness. "This proves nothing," Morrison insists, but his voice carries less conviction now. "Impact resistance. Shell penetration, thermal expansion under combat conditions. The Army has standards. Then let's meet them. What happens next will be debated in engineering circles for decades." Fisher, a civilian with no formal authority, challenging military doctrine. Morrison, an Army engineer, caught between protocol and possibility, and gathered around them. Men who understand that this moment, this demonstration in a freezing factory on a January morning might determine how many of their sons and brothers come home. Morrison makes the call. "Wheateen ores." The welded sample is en route to Aberdeen Proving Ground in Maryland, where the Army tests everything designed to face enemy fire. Within days, it's being subjected to the kind of punishment that makes engineers wince direct shell impacts. Stress testing beyond any battlefield scenarios. Temperature cycling that simulates everything from Arctic winters to desert summers. The weld holds. More than holds. The test results, when they arrive back in Detroit, read like vindication written in technical specifications. Tensile strength exceeding riveted joints by significant margins. Impact resistance superior across all measured variables. No structural weaknesses. No failure points. No reason, technical or otherwise, to reject welding as a primary assembly method. But technical approval is only the first battle. The Chrysler Tank Arsenal alone employs thousands of workers trained in riveting. Entire production lines have been designed around the rivet process. Tools purchased, workflows optimized. Switching to welding means retraining, retooling, reorganizing everything from the factory floor to the supply chain. It means admitting that the approved method, the one that has already produced hundreds of tanks, was never the best method. Some men can't make that admission. Arguments erupt in planning meetings. Engineers defending riveting with the passion of priests defending scripture. They cite precedent, established doctrine, the risks of changing production methods amid. They point to German tank Cs, welded, but also over-engineered, mechanically unreliable, produced in numbers that can't match American output even with riveting. Fisher doesn't attend these meetings. He's not invited. He's back in the factory, welding, demonstrating, training anyone willing to learn. Every whole section he fuses becomes another data point, another argument stronger than any words. The production numbers tell the story that silences debate. A riveted hull, 4 to 6 days of assembly time, depending on crew skill and component availability. A welded hull, 18 hours. The mathematics aren't subtle. 1 production line switching to welding could equal 3 production lines maintaining riveting. Scale that across every tank arsenal in America. And suddenly the impossible becomes inevitable. The Army Ordnance Department issues new specifications in February 1943. Welding approved for Sherman tank hull assembly. Effective immediately. Retrain all assembly crews. Retool all production facilities. The directive arrives without fanfare, without acknowledgement of the civilian pipefitter who made it possible. Just cold bureaucratic language authorizing a revolution. Fisher reads the memo on a factory bulletin board, standing among men who've spent the last month learning techniques he pioneered. Someone claps him on the shoulder. Someone else offers to buy him a drink after shift ends. He declines. There's work to do. Because approval isn't implementation. Because authorization isn't expertise. Because every factory foreman and every assembly crew and every inspector who has spent their career riveting now has to learn a completely different way of building tanks. And Fisher still, a civilian, still without official authority, is about to become the most important trainer in the arsenal of democracy. March 22nd, 1943. Fisher Body Plant, Grand Blanc, Michigan, 5:30 a.m. Dawn breaks over a facility that never sleeps, casting long shadows across a landscape of steel and ambition. Inside, the transformation has already begun. Where riveting hammers once thundered in mechanical percussion, now welding torches bloom like industrial constellations. Dozens of them, hundreds of them, each one a point of fusion, where American resolve becomes armored reality. Fisher moves through the chaos like a ghost haunting his own revolution. He has been assigned, though no official paperwork exists, to confirm it, to train welders across Detroit tank production facilities, Chrysler, Fisher Body, the massive Ford plant in Dearborn. Each factory presents the same challenge. Men who know metal but don't know this. Workers whose hands remember rivets but must now learn flame. The learning curve is written in scrap metal and frustration. Too hot, Fisher says, watching a welder burn through armor plate, creating a hole instead of a seam. You're not cutting. You're joining. Feel the difference. The welder, a man named Kowalski, who's been building car bodies for 15 years, adjusts his torch. Tries again. This time the metal flows without penetrating, fusing along the joint in a bead that looks almost beautiful in its mechanical perfection. There, Fisher says quietly. Now do it 3,000 more times. Because that's what mastery requires. Repetition until muscle memory replaces conscious thought. Until the angle of the torch and the feed rate of the welding rod become instinct rather than instruction. Fisher knows this. He's lived it. Now he's asking hundreds of men to compress months of learning into weeks. Some can't make the transition. You can see it in their eyes. The frustration of skilled workers suddenly rendered novice, of men who prided themselves on riveting expertise now fumbling with unfamiliar equipment. Some transfer to other departments. Some quit entirely, unable to bear the humiliation of relearning their craft. But most stay. Most persist. Because beyond the factory walls, the war grinds forward with arithmetic. that doesn't forgive inefficiency. Every day without sufficient tank production is a day American soldiers face German armor with inadequate numbers. Every hull that takes 6 days instead of 18 hours is a hull that might arrive too late to matter. The pressure transforms men faster than training ever could. The first fully welded Sherman hulls are rolling off production lines with a speed that makes planners revise their estimates upward. Then revise them again. Then abandon estimation altogether and simply count one hull every 18 hours, becoming one every 16. 10, 14, then 12 as crews develop rhythms and refinements Fisher never imagined. The production managers begin to see possibilities. If welding accelerates hull assembly, what else might be The entire factory workflow gets scrutinized, optimized, rebuilt around the new reality. Component staging areas relocate closer to welding stations. Supply chains reorganized to deliver armor plate in sequences that match welding crew rotations. Even the factory architecture changes, ventilation systems upgraded to handle the increased fumes. Lighting repositioned to reduce shadows that interfere with weld visibility. Detroit is reinventing itself in real time. But speed brings new problems. Complications no one anticipated when Fisher first struck his torch in a garage. Welded hulls, being stronger and faster to produce, create bottlenecks elsewhere in the assembly process. Turret production can't keep pace. Engine installation falls behind. Final assembly bays overflow with hulls waiting for components that haven't arrived. The factory becomes a study in unbalanced optimization, one part racing ahead while others scramble to catch up. Fisher watches this with a mixture of pride and concern. He's solved the problem he set out to solve, proved that welding could transform tank production. But he's also unleashed consequences that ripple through systems he barely understands, creating pressures and demands that require solutions beyond his expertise. The Army sends specialists, industrial engineers with clipboards and stopwatches, analysts who map workflows and identify constraints, logisticians who redesign supply chains to match the new production tempo. They descend on Detroit's factories like a technical invasion, bringing order to the chaos that innovation creates. And slowly, inexorably, the entire system rebuilds. Turret production accelerates through its own innovations, casting improvements, machining, refinements, assembly techniques borrowed from other industries. Engine suppliers increase output, expanding facilities and adding shifts. Every bottleneck that welding exposed becomes a problem to solve, a challenge that draws expertise from across American manufacturing. By summer, the numbers tell a story that seems impossible. The Chrysler tank arsenal, which produced 300 Sherman tanks in January, produces 800 in July. Fisher Body's Grand Blanc plant hits similar numbers. Ford Dearborn exceeds them. And across the Atlantic, in North Africa, where American armor finally meets German panzers in significant numbers, the impact becomes tangible. Shermans that wouldn't exist for another year are already in combat. Tank crews who would have waited months for equipment are already engaging the enemy. The production acceleration that welding enabled doesn't just change factory statistics, it changes the mathematics of war itself, tipping scales in directions that military planners hardly dared imagine. But Fisher doesn't see this. Can't see it. He's still in Detroit, still training welders, still troubleshooting problems on factory floors, where the noise makes conversation impossible and the heat makes breathing difficult. He receives a letter in August. It arrives without ceremony, delivered to the Chrysler Arsenal by Army courier. Inside, brief words of commendation from the Ordnance Department, acknowledging his contribution to improved tank production. No medal, no public recognition, just typed sentences on official letterhead, thanking a civilian for doing what the military couldn't do itself. Fisher reads it once, folds it carefully, places it in his workbench drawer beneath layers of technical diagrams and welding rod specifications. Then he returns to the factory floor. Because the work isn't finished. Because every shift brings new welders who need training, new problems that need solving, new refinements that might shave another hour off assembly time. Because somewhere across the ocean, men are climbing into tanks that exist only because Fisher refused to accept that the approved method was the best method. The torch ignites. Metal flows seem to disappear into unified strength, and the arsenal of democracy burns brighter than anyone thought possible. September 17th, 1943. Salerno, Italy. 600 hours. The Mediterranean sun rises over a beachhead where American steel meets European soil, where the theories of production become the realities of survival. Sergeant James Mallory crouches behind his Sherman, listening to German 88mm rounds crack overhead, and doesn't know that the tank protecting him exists for months ahead of schedule. Doesn't know about Fisher, doesn't know about welding, doesn't know about the revolution that happened in Detroit factories while he was training at Fort Knox. He only knows the tank is there. 3rd Armored Division has been in Italy for 3 weeks, pushing inland against German defensive lines that turn every hill into a fortress, every valley into a killing ground. The Shermans, they broad ashores. 68 of them, now down to 43 are. The difference between advance and annihilation. Mallory's tank, nicknamed Detroit Dream by a crew that's never seen Michigan, bears the whole number that production records would show was welded, not riveted. The joints where armor plates meet carry no visible seams, no lines of rivets that might catch shell fragments or create weak points. The crew doesn't notice. Why would they? A tank is a tank when you're inside it, breathing diesel fumes and cordite, listening to your commander call targets through the radio static. But the commanders notice. The maintenance crews notice. The men who repair battle damage and count shell impacts and document every penetration, every failure, every weakness that combat reveals. Lieutenant Colonel Hayes, 3rd Armored's maintenance officer, keeps a ledger that would fascinate Fisher if he ever saw it. 2 columns. Riveted holes and welded holes, and beside each, a tally of combat performance that tells a story the peacetime tests could only approximate. Welded holes sustained fewer catastrophic failures when hit. The continuous bond of fused metal distributes impact stress differently than mechanical rivets, preventing the kind of joint separation that can turn a survivable hit into a crew killer. It's not dramatic, maybe a 5% improvement in survivability, maybe less. But 5% of 43 tanks is 2 tanks. 2 crews. 10 men who climb out of damaged Shermans instead of burning inside them. Hayes doesn't know about Fisher either. Doesn't know that these welded holes represent a civilian's gamble against military doctrine. He only knows what the numbers tell him, what the combat reports confirm. The welded tanks perform better. He writes this in his maintenance logs. In after-action reports that climb through channels toward Washington. Dry technical language describing armor performance, structural integrity under combat stress, comparative analyses of assembly methods, the poetry of survival reduced to bureaucratic prose. But the message travels. By October, similar reports arrive from other theaters. North Africa, where the remaining Africa Corps makes its final stand. The Pacific, where Marine Sherman battalions face Japanese armor in jungle warfare that no one trained for. Every front where American tanks engage the enemy. The data accumulates. Welded holes, better performance, fewer losses. The Ordnance Department compiles the statistics, analyzing combat effectiveness with the same rigor they once applied to rejecting Fisher's innovation. The irony is you aren't lost on some of the engineers, the same men who argued against Weldon now document its superiority in the field. Morrison, the Chrysler engineer who first challenged Fisher, receives these reports at his desk in Warren. He reads them slowly, carefully, the way a man reads his own obsolescence. Every data point confirms what Fisher proved in that January demonstration. Welding wasn't just faster, it was better. He writes a letter that night. Not official correspondence. Not routed through proper channels. Just a personal note, sent to Fisher's home address, because some acknowledgments can't wait for military bureaucracy. You are right. The field reports prove it. I should have listened sooner. Fisher receives it in November, reads it on, files it with the Army commendation in his workbench drawer. He doesn't reply. What would he say? That being right matters less than being useful. That vindication is cold comfort when the work continues. Because it does continue. The work never stops. Production numbers for 1943 tell a story that rewrites what anyone thought possible. American factories produced 29,497 Sherman tanks, a number that seems impossible until you remember it. Represents Weldon as acceleration multiplied across every arsenal, every production line, every shift. Germany, by comparison, produces 5,966 Panzer IVs and Panthers combined. The arithmetic of industrial war has shifted so dramatically that German planners begin making calculations based on assumed American production limits that no longer exist. They estimate Sherman output based on riveting timelines, never knowing that methodology became obsolete months ago. Their intelligence is accurate. Their assumptions are catastrophic. By the time German High Command realizes American tank production has accelerated beyond their projections, the Mediterranean campaign is won, Italy is invaded, and the build-up for Operation Overlord, the invasion of France, is filling British depots with American armor in quantities that make the coming offensive inevitable. Fisher doesn't know this either, doesn't see the strategic implications of his innovation, doesn't understand how production acceleration translates to battlefield superiority. He's still in Detroit, though his role has evolved. No longer training individual welders, that task has been systematized, distributed to specialists who teach Fisher's techniques without knowing their origin. Instead, he troubleshoots, consults, solves the problems that emerge as production scales beyond what anyone imagined. A Fisher body foreman calls him at midnight because weld quality is degrading on the third shift. Fisher drives through snow to the plant, watches the tired welders work, identifies the problem in minutes. Torch tips, worn beyond specification, creating inconsistent flame that experienced welders compensate for unconsciously, but novices cannot. "Replace these every shift," he says. "Don't wait for visible degradation." The foreman nods, makes notes, implements the change. Quality improves. Production continues. Another night, another factory. Chrysler reports stress cracks appearing in hull corners, always in the same location. Fisher examines the welds, the assembly jigs, the sequence of operations, finds that welders are fusing joints in an order that creates uneven thermal stress, metal cooling unevenly and inducing microfractures. Change the sequence, he demonstrates. Corner joints last. After the structure has stabilized, the cracks disappear. Production continues. Small problems. Technical details. The kind of incremental improvements that never make headlines but determine whether production lines run smoothly or grind to costly halts. Fisher solves them because no one else can. Because he understands welding with an intimacy that comes from thousands of hours with torch in hand. Because he's made every mistake these production welders are making and learned from each one. The factories depend on him in ways that no organizational chart acknowledges. December arrives. 1 year since Fisher first struck his torch in a garage, pursuing an idea that had no approval, no authorization, no support beyond his own conviction that a better way must exist. The newspapers don't write about him. The radio broadcasts don't mention his name. There's no ceremony, no recognition, no moment where America pauses to acknowledge that a civilian pipefitter changed the war. There's only the work, the welding, the training, the troubleshooting, the endless, unglamorous labor of making innovation into institution, of transforming breakthrough into baseline. And somewhere across the Atlantic, tank crews, who will never know his name, climb into Shermans that exist because Fisher refused to accept impossible. June 6th, 1944. Omaha Beach, Normandy, France. The English Channel vomits steel onto French sand, a mechanical tide of landing craft and desperation. Among the first waves, Sherman tanks wallow through surf that was never meant to bear their weight, waterproofed and modified, carrying the hopes of Operation Overlord on treads that churn salt water into foam. Technical Sergeant Raymond Cooper's tank emerges from the chaos, engine coughing seawater, vision blocks obscured by spray and smoke. The hull welded in Grand Blanc for months pre-ocean. The temporary waterproofing as the Sherman grinds up the beach toward obstacles that bristle with German defenses. Cooper doesn't think about the hull's construction. Can't think about it. Can only think about the 88mm rounds that begin finding range. About the machine gun fire that rattles against armor like steel rain. About getting off this beach before the tide brings more death and liberation. But the hull holds. Takes a glancing hit from a Pak-40 anti-tank gun that would have torn rivets loose. Would have sent mechanical fasteners through the crew compartment like shrapnel. Instead, the welded joint distributes the impact. The fused metal flexing and absorbing and maintaining integrity even as the exterior armor shows a scar that will never polish out. Cooper's tank survives, pushes inland, becomes one of the hundreds, then thousands of Shermans that pour into France, in the weeks following D-Day. An armored flood that German defenders simply cannot match in numbers or replacement rate. This is what Fischer's innovation built. Not individual tanks, those would have existed regardless, but the sheer overwhelming quantity, the production acceleration that turned what should have been a 1945 invasion into a 1944 reality. The welded hulls rolling through Normandy represent mathematics transformed into momentum. Allied planners had calculated armor requirements for Operation Overlord based on projected production rates, on riveting timelines, on the assumption that tank output would follow predictable curves. Then Welding changed those curves, bent them upward at angles that made the impossible merely difficult. The invasion planned for spring 1945 happened a year early because American factories could deliver the armor it required. Eisenhower doesn't know this. Can't know it. Supreme commanders see logistics in aggregate total divisions, total tonnage, total capability. They don't track the technical evolution that makes those aggregates possible. Don't connect civilian innovations to strategic time, but the impact exists whether acknowledged or not. By July, over 2,000 American tanks are operating in France. By August, that number doubles. The German panzer division's better armored, better gunned, technically superior in almost every measurable way. Face a tide of Shermans that simply cannot be stopped by quality when quantity reaches these proportions. For every German tank destroyed, 3 more American tanks arrive. For every panzer battalion eliminated, replacement Shermans fill the gap before the weekends. The mathematics become existential. German tank production, even at peak efficiency, cannot match American output accelerated by welding. The Reich bleeds armor it cannot replace. And in Detroit, Fischer watches production numbers climb past 4 sounds. Sherman's 4/1944, a figure that seems more like propaganda than reality, until you visit the factories and see the proof rolling off assembly lines. Every 18 hours, every 16 hours, every 14 hours. As crews continue finding efficiencies he never imagined. He reads newspaper accounts of the Normandy invasion, of armored breakouts and tank battles, of American Shermans pushing toward Paris. The articles don't mention production methods, don't discuss welding versus riveting, don't acknowledge that the invasion's success rests partially on technical innovations that happened in factory shadows, far from any battlefield. Fischer doesn't expect recognition. Never did. He's a pipefitter, a welder, a man who solves problems because they need solving, not because solving them brings glory. But sometimes, late at night, when the factory finally quiets, he allows himself to imagine the connection, his torch to those beaches, his technique to those crews, his refusal to accept doctrine to those tank columns grinding through French countryside toward Germany itself. The imagination doesn't sustain. Morning always brings new problems. A batch of armor plate arrives, with chemical composition slightly outside specifications, still within tolerance. Still approved for use, but different enough that welding temperatures need adjustment. Fischer spends 2 days testing, calibrating, determining the precise modifications required to maintain weld quality with the altered material. Production continues without interruption. An experimental Sherman variant, the M4A3E8, with wider tracks and improved suspension, requires hull modifications that complicate the welding sequence. Fischer redesigns the approach, teaches the new technique to factory crews, troubleshoots the inevitable problems that emerge when changing established procedures. Production expands to include the variant, every challenge met, every problem solved, every innovation that emerges from combat experience flowing back through channels to Detroit, where factories adapt and improve and continue the relentless output that keeps armor flowing to Europe. By autumn 1944, American tank production reaches levels that exceed not just German output, but German industrial capacity. Even if every German factory operated at perfect efficiency, even if every resource were dedicated to armor production, the Reich could not match what welding accelerated American production achieves. The strategic implications are profound. German commanders begin making tactical decisions based on assumed American armor limitations that no longer exist. They husband precious panzers, rationing their deployment, calculating that American tank numbers must eventually reach some maximum beyond which production cannot rise. The maximum never arrives. Instead, Sherman production continues its relentless climb, fed by factories that have internalized welding so completely that the technique is no longer innovation, but simply how tanks are built. Workers who learned from Fisher have trained others, who trained others still, creating cascading expertise that permeates every arsenal across America. The revolution has become orthodoxy. In December, Fisher receives a second letter from the Army. This one requests his presence at the Pentagon for a consultation regarding post-war tank production planning. The language is formal, bureaucratic, giving no hint of whether this represents recognition or merely utilization of available expertise. He considers declining. The factories still need him, still call with problems that require his specific knowledge, his particular understanding of welding's nuances and complications. But Morrison, the engineer who once opposed him, who now manages production at Chrysler, convinces him otherwise. They need to hear it from you, Morrison sighs. Need to understand that innovation doesn't come from approved channels and proper procedures. It comes from men willing to challenge what everyone knows is impossible. Fisher takes the train to Washington in January 1945. The Pentagon intimidates him in ways that German artillery never intimidated the tank crews using his work. Endless corridors, offices filled with officers whose uniforms carry more decoration than Fisher owns clothes. Conference rooms where strategic decisions are made with consequences he can barely comprehend. He sits at a table surrounded by colonels and generals and civilian administrators, and explains welding as if teaching another factory crew. The technical details, the production advantages, the combat performance data that validates what began as unauthorized experimentation in a Detroit garage. They listen with the attention of men who've seen the numbers, who understand that American armor's superiority in Europe rests partially on production acceleration they don't fully understand. One General Fisher never catches his name asks the question that matters. Could this technique have been implemented sooner? Before Pearl Harbor? Perhaps. Fisher considers. Honest answer. Yes. The technology existed. The expertise existed. What didn't exist was the willingness to challenge approved doctrine, to risk deviation from established methods. Yes, sir? Fisher says. If someone had been willing to try, the silence that follows carries weight. Implicit acknowledgement that military bureaucracy, for all its strengths, sometimes prevents the very innovations that war demands. That approval processes designed to ensure quality can also ensure mediocrity, that sometimes the best solutions come from civilians who don't know enough to recognize impossible. The meeting concludes. Fisher returns to Detroit on a night train, watching darkness blur past windows, thinking about the question he wasn't asked. How many more innovations are waiting? How many other Fishers, working in garages and workshops, pursuing ideas that official channels would reject? How much potential remains locked behind the walls of doctrine and approved procedure? He doesn't have answers. Only questions. Only the certainty that innovation requires room to breathe, space to file permission to challenge what everyone knows is correct. The train carries him home through winter darkness. And in Europe, the war grinds toward conclusion on treads that Fisher's welding helped forge. The Mathematics of Victory, April 30th, 1945. Somewhere in Germany, 1,400 hours. The Reich dies in fire and rust. Its industrial heart silent. Its panzer divisions reduced to memories and burning hulks, scattered across a continent. Lieutenant Marcus Weber's Sherman hull numbers stamped with production dates that trace back to Fisher's training at Grand Blanc Idols, on a road that was never meant to see American armor this deep into Germany. The war in Europe has 8 days left, though no one knows this yet. Webb's crew sits in spring sunshine that feels obscene given what they've witnessed, what they've done, what still smolders in the German towns behind them. They're counting, not days until victory, that remains uncertain. But tanks. Destroyed German armor litters the road east. Panthers. Tigers. The feared Koenigsegger, with its 88mm gun that can kill a Sherman from distances that make counterfire impossible. Superior machines, every one of them, better armored, better armed, better engineered, and utterly overwhelmed. 17, Webb's gunner says, pointing to a burned-out Panther hull beside the road. 17 German tanks since we crossed the Rhine. How many Shermans we seen destroyed? Webb does the mathematics in his head. Their battalion started with 42 tanks. Lost 11 in combat. But replacement Shermans arrived within sometimes hours fresh from depot stocks that seem inexhaustible. The battalion currently fields 48 tanks, 6 more than they started with. The German Panzer Division they helped destroy started with 60 tanks, ended with 0. No replacements. No reserves. Nothing but wreckage and surrender. This is the mathematics that Fischer's welding enabled. The web will never know the connection. Superior German armor defeated not by better American tanks, but by more American tanks. By production capacity so overwhelming that tactical inferiority becomes strategic. You can lose 3 Shermans to kill 1 Panther and still win. If Shermans arrive faster than Panthers can destroy them. The numbers tell stories that no battle report can capture. Germany produced approximately 6,000 Panther tanks during the entire war. America produced over 49,000 Shermans. The disparity isn't just dramatic, it represents industrial capacity accelerated beyond what any pre-war planner imagined possible, and Welding Fischer's unauthorized innovation. The technique that military doctrine initially rejected accelerated that production by margins that historians will debate for generations. 20% faster, 30%. The exact figure matters less than the consequence. Thousands of additional tanks, delivered months earlier than riveting would have allowed. Arriving in time to matter. The final push into Germany fielded American armored divisions equipped with Sherman numbers that German intelligence consistently underestimated, because their projections assumed production rates that Welding had rendered obsolete 2 years prior. Every German commander who calculated American armor strength based on pre-Welding projections made tactical decisions founded on false assumptions. Every strategic plan that assumed American tanks would remain limited by riveting timelines collapsed when Welding accelerated production delivered armor in quantities that made defense impossible. Fischer changed the mathematics of the war itself, but he's not in Germany to see this victory his innovation helped create. He's in Detroit, where the factories that built invasion continue building occupation. Sherman production hasn't stopped, won't stop until Germany surrenders, until the Pacific War concludes, until every front has sufficient armor to guarantee that American soldiers possess overwhelming material advantage. The Chrysler tank arsenal alone has produced over 25,000 tanks by war's end. Fischer has trained the welders, who built most of them, troubleshot the problems that threatened production, refined the techniques that kept assembly lines running through every crisis. His contribution exists in aggregate, in the sum total of those 25,000 holes, in the production acceleration that can't be attributed to any single innovation but rests heavily on the Welding revolution he sparked. May 8, 1945. Victory in Europe Day. The celebrations erupt across Detroit with the force of released pressure, years of rationing and anxiety and loss exploding into joy. That fills streets and stops traffic and makes the entire city feel like New Year's Eve. And 4th of July compressed into a single ecstatic moment. Fischer watches from his front porch, beer in hand, listening to neighbors celebrate, seeing bonfires lit in intersections, hearing church bells ring their metal proclamation that the nightmare in Europe has finally ended. He thinks about the tanks. Can't help it. Thinks about the Shermans rolling through Germany, about the crews inside them, about the production acceleration that made overwhelming numbers possible. Thinks about the night in December 1942 when he first struck torch to armor plate without permission, without approval, pursuing a possibility that doctrine said was impossible. 3 years. That's how long his innovation took to flow from garage experiment to strategic impact. 3 years from unauthorized welding to victory in Europe. He wonders how many other innovations might exist, might be developing right now in other garages, other workshops, other minds willing to challenge what everyone knows is correct. The thought sustains him through the Pacific War's continuation, through summer months, when Sherman production shifts towards supporting MacArthur's island campaigns, toward the anticipated invasion of Japan that will require armor in quantities that make the European theater seem modest by comparison. August brings atomic fire and surrender before that invasion becomes necessary. The factories receive stand-down orders in mid-August. Production lines that ran continuously for 3 years finally stop. The sudden silence almost painful for workers whose lives have been defined by industrial rhythm, by the constant flow of armor from American steel to European battlefields. Fischer walks through the Chrysler arsenal on the last day of production, watching the final Sherman roll off the line. The workers gather, knowing this moment marks transition from war to whatever peace brings. From purpose that was clear and urgent to futures that remain uncertain. Someone produces a bottle. Someone else starts singing. The celebration lacks Viada's explosive joy, but carries its own weight relief. Pride, exhaustion. The complex emotions of people who've accomplished something they barely understand. The final Sherman sits in the assembly bay, hull welded with techniques that no longer seem revolutionary but simply standard. Obvious, the way tanks are built because welding proved superior to every alternative. Fisher runs his hand along a weld seam, feeling the smooth fusion where separate plates became singular, where his technique transformed from heresy to orthodoxy. No one photographs this moment. No journalist records Fisher's final inspection of the final tank. History has no particular interest in pipefitters or welding innovations or the technical details that determined production rates. History remembers strategy, battles, generals and presidents, and the grand sweep of nations in conflict. The technical revolutions that made strategy possible, the civilian innovations that enabled military success, the unglamorous problem-solving that transformed approved methods into obsolete doctrine. Those stories exist in production records and maintenance logs and the fading memories of men who witnessed transformation without recognizing its significance. Fisher goes home that night to a house he barely remembers living in, to a wife who's grown accustomed to his absence. To children Wouvet spent their entire youth watching their father leave for factories before dawn and return after dark. He's 47 years old. The war has aged him beyond those years, carved lines into his face that no amount of peace will smooth, left him with knowledge. He can never fully articulate that. Innovation requires courage. That bureaucracy resists change even when change means survival. That sometimes the best solutions come from people who don't know enough to recognize impossible. The newspapers publish final production statistics. In September, 49,234 Sherman tanks produced during the war years. The number seems abstract until you imagine them lined up, tread to tread, stretching for hundreds of miles of American steel. Fisher's name appears nowhere in these statistics. No footnote acknowledges his contribution. No asterisk explains that production acceleration rested partially on welding innovations that military doctrine initially rejected. But the tanks exist. The crews who survived in them exist. The strategic advantages that overwhelming numbers created exist. And somewhere in Fisher's workbench drawer, beneath technical diagrams and welding specifications, 2 letters remain. One from the Army Ordnance Department, thanking him for contributions to improved tank production. One from Morrison, the engineer who first challenged him, admitting, "You were right." Fisher never frames them, never shows them to anyone. They're not proof of anything that matters to him, not validation he needed or recognition he sought. They're just paper, just words. Whose word? Just acknowledgement that a civilian pipefitter saw a problem, refused to accept that approved methods were best methods, and changed the war in ways that no one will ever fully measure. The torch sits cold in his garage, unused since August, gathering dust beside the workbench where revolution began. Someday, perhaps, someone will ask Fisher about his war years, about what he did while others fought. "I welded," he'll say. Simple truth, complete truth, and utterly insufficient to contain what those words actually mean. The silence after Thunder, November 11th, 1947. Detroit, Michigan. 1623 hours. 2 years after victory. And the arsenal of democracy has learned to forget. The factories that built 49,234 Shermans now build Fords and Chevrolets. Assembly lines retooled for chrome and comfort instead of armor and survival. The workers who welded tank hulls with Fisher's techniques now weld car frames. The same skills applied to different purpose. The muscle memory of war redirected toward peace. Fisher stands in the Chrysler facility no longer an arsenal. Just a plant watching sedans roll past stations where Shermans once took shape. The building looks the same. Sounds different. The urgency has vanished, replaced by the steady rhythm of commerce, of quarterly profits and market share and concerns that feel trivial compared to what these walls once witnessed. A young engineer approaches, clipboard in hand, face carrying the earnest intensity of someone who has never had to solve problems measured in lives rather than dollars. "You're Fisher, right? The old-timer who worked here during the war." Old-timer. Fisher is 49. Feels ancient. "I welded," Fisher says. Right. The engineer consults his clipboard. "We're having quality issues with the frame joints on the new sedan line. Welds keep cracking under stress testing. I heard you might have some insight." Fisher follows him to the problem area, examines the failed welds, recognizes the issue immediately. Wrong torch. Angle? Inadequate penetration. The kind of mistake he corrected thousands of times during the war years. The kind of error that would have meant hull rejection, production, delay, lives potentially lost. Now it just means customer complaints and warranty costs. He shows the welder the correction. Watches the technique improve, sees quality return to acceptable parameters. The engineer thanks him, makes notes, returns to whatever else fills his day. Fisher stays longer than necessary, watching the assembly line, remembering when this same floor produced machines designed to survive 88mm shells, when quality control meant the difference between crew survival and catastrophic failure. The weight of it presses down. The silence where urgency used to live. No one here remembers. The workers are different. Men, veterans returning to civilian life, or newcomers who never served. People for whom the war is already history, rather than living memory. They weld competently, efficiently, meeting standards that would have been unacceptable in 1943 but are perfectly adequate for automobile. Fisher realizes with quiet horror that his knowledge is becoming obsolete. Not the technical skills, those remain valid, still applicable to any metal joining operation, but the context, the urgency, the understanding of what welding meant when every hole represented human lives, when production delays measured in hours could cascade into strategic consequences. That knowledge has nowhere to exist in peacetime. He thinks about the Sherman sometimes, though less frequently as months become years. Wonders how many still exist in Europe, abandoned in fields or scrapped for metal, their welded hulls outlasting the men who rode inside them. Wonders if anyone examining those tanks would recognize the technique, would understand that hull assembly represents a revolution that military doctrine initially rejected. Probably not. Probably they see only obsolete armor, machinery rendered irrelevant by newer designs, by tank development that continued after the war into realms Fisher can barely comprehend. The world moved on. Fisher's innovation moved with it, absorbed so completely into standard practice that its revolutionary origin became invisible. This should feel like victory, like vindication, like the ultimate success innovation, so thoroughly accepted that it ceases to be innovation at all, becomes simply how things are done. Instead, it feels like erasure. Fisher receives a letter in January 1948 from the Army Ordnance Department. Not commendation this time, but inquiry. They're compiling historical records of wartime production, documenting the innovations and improvements that accelerated armor output beyond pre-war projections. Would Mr. Fisher be willing to provide a written account of his welding development work for archival purposes? For historical record, he sits at his kitchen table for 3 nights, trying to write what happened, trying to capture in words the progression from unauthorized experimentation to strategic impact. The sentences come out flat, technical, drained of the urgency that drove every decision. In December 1942, I began testing welded hull assembly as an alternative to approved riveting methods. Initial results showed promising improvements in both speed and structural integrity. True words, accurate words, completely insufficient words. How do you write about standing in a freezing garage, pursuing an idea that had no approval because you couldn't accept that better methods didn't exist? How do you capture the resistance, the skepticism, the institutional inertia that nearly prevented innovation from ever reaching production lines? How do you explain what it meant to train thousands of welders knowing that every technique you taught might save lives? You'd never meet in battles you'd never see in a war whose outcome partially depended on production acceleration you enabled. Fisher tries, fails, settles for technical description that satisfies the Army's request, but betrays everything that actually mattered. He mails the account in February, never hears back, assumes it's filed somewhere in Pentagon archives, gathering dust beside thousands of other technical reports from men whose contributions shaped the war in ways too small or too specialized to merit broader recognition. The silence doesn't surprise him. never expected fame, never sought recognition, but the forgetting the systematic cultural amnesia that transforms revolution into footnote, into nothing that wounds in ways he couldn't articulate. March brings Morrison to Fisher's door, unannounced, carrying a bottle of whiskey and a manila folder, thick with documents. "Thought you should see these," Morrison says, settling into Fisher's kitchen. "Combat analysis reports, final assessments of Sherman performance across all theaters." The documents represent years of data collection, thousands of after-action reports compiled and analyzed by Army statisticians trying to understand what worked and what failed. Tank survivability, crew casualties, armor performance under different combat conditions. The welded hulls features innovation show consistently better performance metrics, not dramatically better. Not enough to overcome the Sherman's tactical disadvantages against heavier German armor, but measurably, statistically, meaningfully better. 5% improvement in survivability, 7% reduction in catastrophic hull failures. Margins that seem small until you multiply them across 49,234 tanks, across hundreds of thousands of crew members, across years of sustained combat. The mathematics suggests Fisher's welding saved hundreds of lives, maybe thousands, if you account for indirect effects. 4 tanks that remained combat effective instead of being knocked out. 4 crews that survived to gain experience that kept them alive in subsequent engagements. Morrison watches Fisher read, understanding without words that this is the recognition that matters. Not medals or commendations or newspaper articles, but proof that the work meant something, that innovation translated to survival, that refusing to accept approved methods as best methods actually mattered. "You changed the war," Morrison says quietly. "Might not see your name in history books, but the men who climbed out of burning tanks instead of dying in them, they're your legacy. Their children, their grandchildren, all the futures that exist because welded hulls held when riveted joints would have failed." Fisher pours whiskey. They drink without toast, without celebration, just quiet acknowledgement of something that can't be adequately expressed in words. The evening passes. Morrison leaves. Fisher files the combat reports with his other documents. Commendation, the letter from Morrison during the war, the technical diagrams and welding specifications, evidence of a revolution that no one will remember. He returns to work the next day at the Chrysler plant, fixes weld quality issues on automobile frames, teaches techniques to younger workers who don't know and don't ask where these methods originated. The work continues, different purpose, same skill. Metal flows, seams fuse, separate pieces become unified strength. Andina rope, rusting in fields from Normandy to Berlin. Sherman tanks weather toward oblivion. Their welded hulls will outlast the crews who rode them, will persist decades beyond the war they fought. Silent testimony to innovation that saved lives no one can count, in battles no one will remember with precision. Fisher's name appears nowhere on these hulls. No manufacturer's stamp credits the civilian pipefitter whose unauthorized experimentation changed how they were built. But the welds remain. Will remain. Fused metal that refuses separation, that holds integrity even as rust consumes the armor around it. Years from now, when historians study Sherman production, they'll note that welding replaced riveting in 1943. They'll document production acceleration, improved combat performance, strategic advantages gained through superior manufacturing. They probably won't mention Fisher, won't trace the innovation to a December night in a Detroit garage, to a man who challenged military doctrine because he couldn't accept impossible. History rarely remembers the welders, remembers the generals, the battles, the grand strategic decisions, forgets the technical revolutions that made strategy possible. Fisher understands this, accepts it, returns to his garage on quiet evenings, where the torch sits cold and unused, where revolution was born in unauthorized flame and fused metal. The silence after. After thunder, the forgetting after sacrifice. The ordinary life that follows, extraordinary contribution. He lifts the torch once more, just to feel its weight. Just to remember what it meant to hold fire in your hands and refuse to accept that approved methods were best methods. Then, sets it down. Tomorrow brings automobile frames that need welding, Quality issues that need solving. Younger workers who need training. The work continues. It always continues. And somewhere in Pentagon archives, a technical report gathers documenting in flat bureaucratic prose what Fisher accomplished. Welding innovations implemented by civilian consultant. J.D. Fisher resulted in significant production acceleration and improved combat performance across all Sherman tank variants. 14 words. Entire revolution reduced to single sentence. Complete. Truth. Utterly insufficient.